Okay, so topic E, it's called new functions from old. We're basically talking about different ways that we might manipulate and transform some of our functions. So first thing I want to do, we're going to review transformations a little bit. So not a new topic, you did them in Algebra 1, Algebra 2, college algebra, so we've seen them before. But let's make sure we remember. So if you take a function and add something, what does that do? If I said like x squared plus 4, moves it up. What happens if you subtract? Down. Okay, if I add on the inside, if I do like x plus 2 squared, what does that do? You add to the x, you move it to the left. So if you subtract from your x, that would move it right. Okay. If you have a number out in front and you multiply by that number, that is actually a vertical stretch or shrink. It's like taking all of your y's times the number. So if the number is bigger than 1, it stretches it, it makes it get taller. If your number is smaller than 1, then it shrinks it, makes it get smaller. Inside affects x. So if you multiply on the inside, it's a horizontal stretch or shrink. What do negatives do? Flip it. A negative on the outside is like making all of your y's negative, so it flips over the x-axis. And a negative on the inside makes your x is negative, so it flips over the y. Any questions? Okay. So let's look at some examples. First one, I'm just going to put one parent function up here and we're going to graph a lot of different transformations to it. So let's start by graphing the parent function y equals the square root of x. When I had you graph these, what were my guidelines? How many points did I make you do? A minimum, if you were going to graph anything. 3 exact points. So we can't plug in negatives here. Square root of 0 is 0. Square root of 1 is 1. Next number you could do square root of would be an 8. Sorry, not an 8, a 4. Let's do a cube root. Square root of 4 would be 2. You could go to 9, 3 if you wanted. And remember when we graphed the parent function, we always made those dashed. that is my parent. If I said y equals the square root of x with a minus 2 on the end, what is that doing? Down 2. So if I moved each of my points down 2, look at that. Okay, when I have the square root of x and the minus 2 is on the inside, what's that? Right 2. So take your original parent function and move each of your points to the right. And you could do these on separate graphs if you want to. I'm just putting them all in one. Okay. Next one. If you put a negative out in front, what does that do? It's like making my y's negative. So flip over the x. Is that going to confuse you if I keep doing these on my same graph? So if this is already on the x-axis, it stays, and then these would come down. All right, last two. A 2 radical x. What does the 2 do? Look at your notes. If you multiply by something out in front, what is it doing? Vertical stretch. It's like taking all my y values times 2. So this originally was at 0. 0 times 2 is still 0. This has a y value of 1. 1 times 2 is 2. This has a y value of 2. 2 times 2 is 4. So we get this really tall graph. And the last one. The negative is under the square root. So what's that do? Make sure x is negative so it flips over the y-axis. So original one reflected the other way. of recapped all of our transformations in one example. Something we are going to do, we did it back in college algebra. I want to use transformations to graph this quadratic. I can't just look at this and say it's going to move up 10 because it's not written as an x squared with something added or subtracted on the outside. So on this one we have to complete the square. So if you remember, completing the square, you group your x's together. We're doing this a little bit different because we're keeping everything on one side of the equation. And I'm going to keep my constant on the outside. Then, to complete the square, you take your middle term, always divide by 2, and square. So 6 divided by 2 is 3, 3 squared is 9. So we add a 9 to this. Now here's where it's a little bit different. When you have two sides of an equation, you would add 9 on each side. I am working strictly on this side, so I have to keep it balanced. If I add 9 on this side, what else do I have to do on this side to balance that out? Subtract 9. So I'm going to put a minus 9 out here. Then this is a perfect square, so it factors into something squared. So we know there's an x, and the easy way, I told you, just look right here before you squared. 6 divided by 2 is positive 3, so it's an x plus 3 squared, and then we have a plus 1. Okay, so now we can do transformations. What are my transformations on this one? Left 3 and up 1. So if I were going to graph this, parent function is x squared, 0 squared is 0, 1 squared is 1, negative 1 squared is 1. We're just talking about a parabola. And then I need to take each of those points to the left 3 and up 1. Why don't you guys try B? So we group our x's together, keep the minus 21 out here. Middle term is negative 4 divided by 2 squared. So negative 4 divided by 2 is negative 2. When you square that, it's positive 4. So you have to put a minus 4 on the outside. So this factored into x minus 2 squared minus 25. I did not give you a very nice problem, did I? Did everybody get to that point? Okay, so your transformations this time would be right 2 and down 25. I'm probably not going to do that real precisely. So your original would look something like this for your parent them 3 exact points. And then you can move them all over and down. Is that one okay? I want to do one more. Completing the square requires that this leading term be a 1x squared. So I want to do one that was not. Okay, so we still start out grouping those together. But what we're going to have to do before we can complete the square, we actually have to factor out this 2. So if I pull that out, that would give me a 1x squared minus a 3 over 2x. And I don't have to worry about the 1 because I did only pull the 2 out of my parentheses. So now you take your middle term, negative 3 over 2, divide that by 2 and square it. So negative 3 over 2 divided by 2 is negative 3/4. Squared would be 9 over 16. So I'm adding 9 over 16 here. You have to be very careful though. I can't just put minus 9 over 16 on the outside. Does anyone know why? If I were figuring out what I really added here, if I multiplied this all out, what would I do with my 9 over 16? I'd have to take it times 2. So 9 over 16 times 2 is 9 over 8. That's what I have to subtract to keep it balanced. Have I lost anybody? So now we just proceed like the rest. So we have our 2. This is x. If you could just look before you squared it, it was negative 3/4. So x minus 3/4 squared minus 17 over 8. I'm not so much concerned with the graph on this one. I just wanted to make sure you could handle completing the square if your first coefficient was not a 1. Questions on that one? Let's do this one. Y equals negative absolute value of x plus 1. Okay. So on this, do you guys remember what your parent function looks like? What does your absolute value graph look like? It's a V. If you don't know, you can always make a table of values. Absolute value of 0 is 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. You only have to have 3 points. So there's my parent function, which I expect you to graph on every one. And then we have 2 things. The negative, it's on the outside, so it's making my y's negative, so it flips over the x-axis. The plus 1, it's on the inside, so it does the opposite of what you think. It's adding moves it to the left. So So if I start at 0, 0, if I flip that, it doesn't go anywhere, and left 1. Negative 1, 1. If I flip it, moves down, and then left. Any questions there? I want to move on a little bit from transformations. I want to talk about domains a little more. So I want to find the domain of each of these things. I'm going to try to make it bigger for you, but I guess I don't have it all grouped together. So find the domain of f times g if f of x equals 1 over x and g of x is the square root of x minus 1. Okay. So we have to first, I didn't ask you to actually take f times g, but it's a good starting point if you're wanting to find your domain. You could easily do that. F of x is 1 over x. G of x is the square root of x minus 1. And this is just over 1, so if you multiply fractions, you just multiply the tops. So 1 times radical x minus 1 is radical x minus 1 over the bottom. So if I need to find the domain of this, there's two issues. First of all, I know that since x is on the bottom, x can't equal what? 0. I also know because I have a square root, whatever is under my square root has to be greater than or equal to 0. So if I add my 1 over x is greater than or equal to 1. I need to put those together into the most concise domain that I can. If x is greater than or equal to 1, do I have to worry about it equaling 0 anyway? No. So for my domain, I could really ignore the 0 in this case, because I already know it's something bigger than 1, and just write that interval. If you bracket 1, comma, infinity. Alright, second one, f plus g. F of x is the square root of x plus g of x is the square root of 2 minus x. Can I actually add those and get anything? No. Okay. If I'm looking at the domains, first one's under a square root, so I know it's got to be positive, so x is greater than or equal to 0. Second one is also under a square root, so 2 minus x is greater than or equal to 0. If I add my x over, I get 2 is greater than or equal to x, or x is less than or equal to 2. I have to somehow put those two things together. What this tells me The first one is anything bigger than 0. The second one is anything smaller than 2. My domain is the thing that makes them both true. So which portion of this works for everything? Between 0 and 2. So if you bracket 0, comma 2. So any number between 0 and 2 would work. Is that all right, everyone? Last problem of the day, f divided by g if f of x is x squared, sorry you can't hardly see that square, and g of x is x minus 1. So f divided by g would just be x squared over x minus 1. It's a fraction, so what do you know right now? Bottom can't be 0. So x can't be 1. So my domain would be negative infinity to 1, union 1 to infinity. We are not done with this section by any means, but we have started it. I passed out several things to you guys. The first one, the trig handout, is the information from topic D. There is a staple page on the bottom. This is the topic E homework, so this is starting what we did today. We are going to spend several days on this section, probably 3 to 4 days, depending on how it's going. So I'll make up my mind when I see, but you guys can start this. You really could do up through, well, you could do problems 1, 2, and 3. You could do problem 5A at this point. You might be able to do a few others if you remember things from last year. So you can get started on this. Tomorrow, instead of teaching more of this section, I am flipping things a bit. I really wanted to do a quiz over topics A, B, C, and D, so I passed that out to you as well. So it's really kind of a take-home quiz. That's tomorrow. Our strictly online day, you're working on this take-home quiz. You guys will turn this into me the next time I see you, which would be on Friday. So you can start the topic E handout now. The quiz, I'm grading it like a quiz. So show absolutely all of your work. It'll be graded just like any other quiz, and you'll turn that in on Friday. And then Thursday, when you're online, I'll work some more of this section. Is that clear to everybody?